The purpose of this lesson is to learn what replication is and how it works, different ways that replication can occur, how MySQL handles replication, the difference between slaves and the master, the importance of the binary log, how to configure MySQL to enable replication, and how to troubleshoot replication. Replication is the use of fault-tolerant resources or computers to create duplicate copies of data to increase performance and also to increase reliability and availability. Now, this requires sharing information between the resources, and it is different than clustering. Some of the benefits to replication are that we can do what is called a scale-out solution, which is we take the load that would typically be on one computer and we actually spread that load out amongst multiple other computers. Now, what happens in the MySQL environment is writes have to occur on one computer called the master, and then we can have multiple computers called the slaves that those can be used for doing lookups. So if I have an environment where I have 3 different warehouses, then what I'm going to do is I'm going to make one computer at my main location, the master, and anytime I want to perform any updates, if I want to create new customers, if I want to change somebody's balance or something like that, that actually gets applied on the master. And then what will happen is all of my warehouses or all of my other locations, they have their own MySQL server that automatically downloads a copy of that data, and they will be doing all their lookups on their local computer. So it'll help save network resources, and it will also help save read-write access on the master. Now, it also allows for what we call data security. Now, please note that this is different than what we usually think of security. What we're talking about here is that we have the ability to save the data. Now, when we do a backup, we cannot do a backup on our master server when users are in. So what we have to do is we have to lock everybody out to do backups. Well, if I have slaves set up that have duplicate copies of all the data that is on the master, then I can do a backup on the slaves at any point in time. And by doing that, I don't have to bring the master down, I don't have to kick users out, only the users that are on the slave that's actually being used to perform the backup have to get out. I can also use it for analytics. When I do analytical queries, I'm trying to pull up a large amount of data at the same time. Let's say I want to see information that occurred over a large period of time. I want to aggregate some data from different tables. Unfortunately, that actually has a very severe performance hit on the database server. So what I can do is I can have one slave set up that just simply has a copy of all the data that's on the master, and I can perform whatever queries I want on that computer, even if they're rather intensive, and it will not affect anybody else in the environment because that server is the only one that would have the performance hit. We also have the ability for what is called long-distance data distribution, which means that we can have branch offices that have a dedicated server, and they can be what's called synchronous, which means that they will always download all of the records, so they're always connected and they're always checking for updates. Or we can have them periodically log in and download the updates. So what I can do is if I have a location that's out in the middle of nowhere, it only has a dial-up line, and we only have one telephone line, what we can do is we can configure the system that once an hour or once every 3 hours, once every 6 hours, or even only once a day, it signs into the master and downloads a copy of all the data. So we have different replication types. We have what's called asynchronous, which means that the updates occur on the master and then the changes are replicated to the slaves. Now, the way that this works in MySQL is that all of the updates are placed in the binary log on the master, and the slaves will retrieve the binary log and then they replicate it on their own server. So I update something on the master, the slave will see that there's a new entry in the binary log, it downloads the whole log, updates itself, and just simply issues the same query. Now, synchronous replication is when I would have a cluster, which this is not a cluster, we're doing simply replication. But essentially what that would be is that my program is required to place the update on all of the servers at the same time. Then there's also what's called semi-synchronous, which is supported by MySQL. And what will happen is that I want to ensure that at least one of my slaves gets the data. So that way if something happens to the master, the data doesn't get lost. So what will happen is I write the data to the master. It blocks anybody else from performing any commits until at least one slave acknowledges that it received the data. The last option is what's called a delayed. And delayed is that the slaves are deliberately lagging behind the master by a set period of time. So let's say I only want them to check once an hour. I want them to check every 3 hours or so forth. What this would allow me to do is I could set up one server that only checks in once a day, and I can compare information from today to yesterday based on what the slave has. There are different types of replication formats. There is statement-based replication, which is the default one that's used by MySQL. The entire SQL statement is replicated. So what happens is if I update a customer's balance on the master will store that information in the binary log. The slaves download the binary log, and then they just simply reissue that statement on the slave. The next option is what's called a row-based replication, and that one is if I make any changes to rows, it would actually be stored in the actual journal, and the slaves can get it from there. That one is not used by default. By default, we use the statement-based. We can also use mixed-based, so we could allow the slaves to download the binary log and the journals and get their data that way. By default, we're going to use the statement-based replication, and that's what I'm going to show you how to set up in this lesson. Now, they say that the master is dumb, and essentially what that means is the master is used for all of our updates. The master has all of the information on it. It can do everything. And what happens is every single query that is issued to the master gets stored in the binary log. Everything gets stored in the binary log. I cannot filter out specific information. Everything gets put in the binary log. So what happens is all the data that is on the master actually gets downloaded by all of the slaves. Now the slaves receive the entire binary log, and they need to know where to get that from. That's called the coordinates to the binary log on the master. And they are going to download the whole file, but the slaves actually have the ability to only import specific information. So what I can do is I can set up filters that allow me to only import things like customer balances or new products or things like that. But the slaves are the only ones that get to make that decision. The master does not. The master is going to replicate everything. The slaves can also connect and disconnect at any given point in time without affecting the operation of the master. So to enable replication, we have some steps that we need to go through. The first thing is we need to enable the binary log, and we need to give it what's called a base name, which we actually covered this in a prior lesson. I will show you again how to do it today. But we need to know where the binary log is saved. And we also need to know what the binary log is going to be called on the master, because what happens is on all of the slaves, we have to tell them where to locate the binary log. We also need to set the server ID, and typically what we'll do is we'll set the server ID on the master to number 1, and then we'll set the server ID on the other workstations to numbers 2 and above. Does it really matter what they're named? No, but they just all have to be unique. So make sure that you figure some sort of scheme for numbering them, that you know which one is which. So we can set the server ID from a command line. We can use the MySQL executable application to set the server ID, or there's actually a query that we can use that sets what's called a global server ID. Now the global server ID is actually going to override the MySQL command, so we actually want to use the SQL query. And then after we do that, then we can look and see what the server ID is by showing the variable name. There's a variable called variable name, and look and see what server ID is set to. We covered that in the prior lesson, but I'm going to show you how that works again today. The next thing that we need to do is we need to create a user account on the server that has a privilege to actually perform replication. There is a global privilege that needs to be set that allows for the replication. So we're going to create a new user account. We set a password for it. One of the limitations is that the password cannot be any longer than 32 characters in length. It cannot contain pound signs, because a pound sign is considered as a comment in the my.cnf file or my.ini file. So if we store the password with the # in it, we cannot modify anything from the command line or through the my.cnf or my.ini files. We also need to create a data snapshot on the master before we do anything on the slaves. And the reason for it is the database has to exist on the slaves before we can start the replication. So what will happen is we do a dump on the server, and then we import that data onto the slaves, and then we can actually start our database server. So we actually have to kick all the users out to perform the dump, and then we want to keep all the users out of the system until all of the slaves are online. And the reason for that is if I don't stop processing, then what will happen is we'll end up with inconsistent data. So I've done a dump, and I have all of our customer information, and if the production server is still up and running, then what may happen is somebody may change a customer's balance, and then when I put the dump on the other computer, on the slave, then the balance is going to be what was in the backup, not necessarily what the new balance is. Now, theoretically, MySQL should pull in the data from the master, and it should give the new balance for that customer, but it's not always going to do that correctly. Alright, so I'm in the MySQL Workbench, and the first thing that I need to do is I need to create a user account that can be used to perform the replication. So I'm going to go into Management, and I want to go to Users and Privileges, and I'm going to add an account. And my account that I'm adding by default will be called New User. I'm going to call it Replication User. It doesn't matter what you call the account, but you need to remember what the username is, and like I said, make sure it's no longer than 32 characters in length, same with the password. The authentication type is going to be standard, and notice it says limit to host matching. Now the catch is going to be that this is the wildcard, which means that this user can sign on from any computer. If I want to limit the user to be able to only log on from a certain server, like let's say I want to set a specific slave, I can do that. I can lock them down by IP address, and that is actually how I want to do the replication, because I don't want somebody to have another computer out on the internet that figures out that I have a replication master, and they figure out my username and password for them to be able to sign in and get that information. So I'm going to set up a password, and in this case I'm just simply going to call it password. Notice that it is going to be a very weak password, but I'm just simply doing this because it's an educational environment. If you're actually doing this in a production environment, please don't use the word password. One of the things that I need to do, though, is I need to give this person the ability to do replication. So under administrative roles, I have options here for what they're actually allowed to do. And so if I look at role, I have one called Replication Admin. I'm going to select this, and what it actually does is over under Global Privileges, is it allows it to be the replication client, slave, and it also gives it a super privilege, which means that it's allowed to do maintenance tasks on the database. So I'm going to apply it, and now I have my replication user account. After we create our user account, we need to lock everybody out of the database so that we can do our replication changes, so we can do our backup and so forth. And so to lock everybody out, what I need to do is I need to put a lock in place on the tables. And the easiest way to do this is through a flush tables command. What flush tables does is it allows me to put a lock on all the tables, and then what it does is it clears out the cache in memory used by those tables. It doesn't actually delete the data from the table itself. It deletes the cache. But what happens is it locks all the users out, and the lock will remain until the session is closed. So I actually have to type a command to remove the lock. So once I remove the lock, then I need to find out where my binary log is, and I'm going to do that on the master by issuing a command that says show master status. Alright, so in the workbench, I want to perform a flush tables with read lock, and then when I run this, I'll just simply get a message that 0 rows are affected, but it was successful. But what it actually just did is it placed a lock on it, so if I try to update data in the database, it actually will not let me do it. Alright, so I want to see my master status, so I'm going to say show master status. And it shows that the master is actually looking for a binary log called computername.00001. Now I configured this in a prior lesson, but what I want to show you is from the beginning how you would configure this. So when I pull up the my.ini file, you will notice that the data that's in it is the default. Alright, so the my.ini file is located under the C drive under program data, which from a prior lesson I explained this is a hidden folder. So you need to make sure that you either type program data in or turn on hidden files and folders, MySQL, MySQL Server 5.6 or whichever version you have installed, and the file is right here. It's called my.ini, and I want to edit this, and we're just simply going to edit it in a text editor such as Notepad or Notepad++, or depending on what system you're in, you can use any text editor. And what I want to do is I want to scroll down, and there's information on the server, things like the clients, how they connect, what character format we use, so what kind of encoding. Do we enable named pipes? Do we allow shared memory? Things like that are enabled. And so what I'm looking for is actually an entry here that says binary logging. Now the binary log by default is turned off, and I need to turn it on. And the way that I'm going to turn this on is I'm simply going to type in the name of the computer, or I could call it master, or whatever else I want to call it. But so for this example, I'm just going to call it computer name. And what this is this is the base, which means my actual file names for the binary log are all going to start with computer name and then a dot and then some numbers after it, and they're all numbered 1, 2, 3, 4, and so forth. So once I turn this on, then that's what I get. Now the other thing that you'll notice is that our logs are all based on the name of the computer, so this is what my actual computer is called. I can change the name of the logs if I want. That's for my benefit. The binary logging is the one that I really care about because that's the one that's used to replicate the statements from one computer to the next. Once I set the base for the binary logging, I need to save it. And then I need to stop and restart the MySQL Server service. Now I can do that through Windows by restarting the service, or I can do it from the Workbench. Under Management, there's an option to start up and shut down. And right now the service is running. I want to stop it. It'll prompt me with the UAC, that's normal. And so what we're going to do is we're going to stop it, and then once it's stopped, we'll go ahead and restart it. Now that I've restarted the service, I now will see that I have binary log files located under Program Data, MySQL, MySQL Server 5.6 Data. This is the default path where I can find those files. So what I'm looking for is a file called computername.00001, and remember from the previous lesson, this is the one that stores all of our SQL statements. Be careful because this one does store things like usernames and passwords in it and other sensitive information. Now that I have it enabled, I also can come back in and rerun my show master status. It should still show that I have a master log file, which I do here. It's called computername.00001, and notice the position actually changed. It was originally 3000 something. It's changed its location. That's okay because I've created a brand new log file. The next thing that I need to do is I need to set my global server ID. So I'm going to use the command set global server _ ID, and we're going to set this equal to 1. And now my server ID is 1. So what this is doing is it's going to set it where I can identify the system that I'm on based on what the server ID is. Remember, I want to set the master to 1, and I want to set all the slaves to numbers 2 and above. The numbering doesn't matter, but they have to be unique. If I want to see what my server ID is right now, I can look at the variables, just like we did in the prior lesson. So show variables, where variable name is equal to or like, either one would work with this one because I'm going to type the entire name out, server _ ID. And when I run this, I will now see that my server ID is 1. Now my master is running on my physical machine. My slave for this example is running through a virtual machine, but it will function the same way that it does in a production environment. So the virtual machine is running in VMware, and what I've done is I've called the instance of MySQL local slave. That way you can tell the difference between the slave and the master. So what I need to do on my slave is I need to set the server ID also. So I'm going to set global server ID, and this time I'm going to set it equal to 2 because remember our slaves have to be 2 and above and our master is 1. So in this case I'm going to set the global server ID to 2, and then now I want to verify that that is correct. So I'm going to show variables where variable name is equal to server ID. And now what I should see is that my server ID is 2. I'm going to resize this so I can see a little bit more information in my output window here, but my server ID is set to 2. once I have the ID set for the slave, then I simply have to tell the slave that it is a slave, and I have to tell it where to locate the master. By default, each slave will think that it is the master, and I need to tell it it's not the case. So we're going to use a command called change master, and we're going to give it whatever the host name is of that computer. We're going to tell it the username and the password that we're supposed to be using, and also what the name of the binary log file is. By default, it will try to figure out the coordinates to the file. All I have to do is tell it what the name of the binary log file is. When we're done setting this, we have to do a couple of things. First is we have to stop the slave service, we have to start the slave service, and then restart the entire MySQL service. So in our slave, now that I know that it is set to server ID number 2, I can change the master. And so I'm going to issue the command change master 2, and then now to make this easy on myself, I could type this whole thing out as one command on one line, or I can actually type it on multiple lines. And if I type it on multiple lines, it will ignore the white space. And what it does is it makes it a little bit easier for me to see that I've typed everything in correctly. So I'm going to change master host, equals, and then the name of the computer, which in this case, my computer name is skgt-2200-LBP. Doesn't really matter what it's called. And then I put a comma, and then the next line is going to be master user. Now this is going to be the user account that I created, and the user account that I created was replication user, comma, and then the next thing is the master password. Now notice this is not the actual password for the master accounts. This is just simply what is the username and password on the master that I've set up that we are allowed to use replication with. So we're going to set this equal to, and his password was just password, which, like I said, is very insecure. Don't do that on a production environment. And then the master log file is equal to, and this is what we need to know, is what the actual log file is called. Now, in this environment, I know that it's called computer name, and there's some numbers afterwards. Well, in this case, it put 5 zeros and then a 1. And I need to know exactly how it's set out in that folder. So I'm going to put in here computer name, and this has to match exactly. So 1, 2, 3, 4, 5 zeros, a 1. Close this, and then we're going to put our semicolon to finish the statement. When I'm sure I have this correct, I can execute it. And I actually got an error that says that it cannot be performed when it's running a slave. So what it wants me to do is issue a command to stop the slave. So I'm going to say stop slave, run that, and now I should be able to change my master. Okay, now it does give me 2 warnings, and if I hover over this, it'll tell me that the password is stored in clear text, that we should consider using encrypted method like SSL. You actually do have the ability to set this up, and those are added capabilities here, but it's right in the change master. Instead of setting master user master password, we can set master user SSL and master password SSL, so we can actually configure secure. For the sake of this example, just so you can watch what it does, I'm going to leave this in plain text. Alright, so I have configured this. I stopped the slave, so now I need to start it. Go and run this, and we should now be a slave. Alright, so I need to figure out some things, like essentially I need to find out if my slave is working correctly. How do I do that? So after I configure the slave, I want to check the status by issuing a command called show slave status. And then if there are no error messages, I'm good, but if there are error messages, I'll show you where to find the message. Those are actually going to be in the MySQL reference manual, or you can just simply do a search online to find out what those error messages mean. Alright, so I want to show the slave status, so show slave status, execute this, and I will get output that will show to me the current status of our slave. It'll show who the master is, the username, the port number, which this is going to be important, I'll show you in just a minute why, the computer name, the master log base name, which is computer name, and then if I scroll across to here, I will actually see if there are any error messages. And if I look here, it says got fatal error 1236 when reading data from the binary log. And it wants us to check. So if I hover over this, I can see what it is. It says client requested master to start replication from position. And the file size that it's looking for is actually greater than what the file size is expected. And like I said, these error messages, if you look in the MySQL reference manual, there are all sorts of messages that you will receive. The reference manual, the community boards, they all have solutions for a lot of these error messages that you may encounter. Now this error message you'll get sometimes if the master crashes, or if the file gets corrupted, or if for some reason the master decides to restart the binary log file. What will happen is the error message is that it's trying to look for a master log file that is bigger than what really exists on the server. So what you want to do is you want to look at this error log, and when you come across here, it tells you that it's expecting the file to start at 4. That's the last size that the actual binary log is experiencing. So what I need to do is I need to tell this computer, the slave, to start looking at the master log file at position 4, not at the position where it's trying to look at, because it's right now trying to look at a larger position that doesn't exist. To fix this, I'm going to reissue my change master to, and I'm going to add an extra line to it. And so this time what I'm going to say is that the master log position, POS, is equal to 4, because that's what it's expecting in, or that's what it's finding in the log file. So I'm simply telling it that, okay, I want you to restart at position 4, and so we'll execute this. And what will happen is it should now allow me to do my replication. So now if I come back to my show slave status and I run this, now I should be in some sort of event that's showing that it's trying to look at the master. And if I scroll over to where the error messages should be, you'll see that I now have no error message. So what happened was, in this case, it was looking for a file that was the wrong size, or it was looking for the wrong position in the existing file. If you're trying to troubleshoot the messages that occur, some of the more common ones that occur are that the firewall on the master may be blocking the port that's required for MySQL. Now, you may have told it during the installation of MySQL that it's allowed to open a port, but it will only open the ports on private and domain networks, and if your computer is accidentally set to a public network, it will not be enabled. You'll either have to change the network type, or you will have to enable the port on that particular network that you're on. And the port number that you're looking for is port 3306. You also want to make sure that you can ping the master from the slave, and if you're able to ping it, try to telnet from the slave to the master. So you just simply do telnet space, whatever the name of the master computer is, space, and then 3306, so you can tell it to connect on port 3306. If it's successful, you will actually show a connection message to MySQL. Verify that the binary logging is enabled on the server. So what I want to make sure is that I actually do have a binary log that exists under the data folder. I want to make sure that each server has a different server ID, and I want to make sure that the user account that I created has a username and a password that's correct, but also that that user account has the global privileges to do replication. I also want to make sure that that user account, its username and its password are no longer than 32 characters, and that the username and the password, neither of those can contain a pound sign. Alright, so my replication should be working. I want to look at the classic models customers table to see what information I have in here. So I'm going to do a select all statement, and I'm going to do this in the database dot table format. So classic models dot customers, and now when I execute this I should get the entire table. And I want to play with the last name of this particular customer. Right now it's Smith. Maybe this person gets married and their last name changed to Jones. So what I want to do is I'm going to update the actual table to allow me to change their last name, and I want to see if that will replicate over to the other server. So I'm going to update, and it's classic models dot customers, and we're going to set the customer last name, and we're going to set that equal to Jones, where the customer number is equal to 112. Okay, so if I execute this, we should get that it was successful. I want to see that that actually worked. So now the last name is Jones. So for this particular customer, Sue now has the last name of Jones. Now, like I said, for this to work, I would have to do a backup of the database on this computer and restore it on the other computer. And I showed that to you in a prior lesson. But to do the backup, you go to Management. We're going to export data on the other computer. We just simply import it. You want to do that before you set up all the replication. But in this case, I want to make sure that this actually did work. So now I'm going to go ahead and check on the other computer to make sure that the replication actually occurs. All right, so back on our slave computer, I want to see if that actually did go through. I do have the classic models because I restored it to the server before I did all the replication. And so what I want to do is I want to select everything from classic models .customers. Run this. And I will see that Sue now is Sue Jones. So I didn't import her information here as Jones. I imported her information as whatever it was beforehand, which I believe was Smith. So what happened is I imported the data as Jones, and then the server automatically replicates. So if I want to verify that that works, I'm going to put her back to Smith. And so I'm going to issue the query where I want to make her as Smith. We will execute this. She's now back to Smith, and I can verify that in here. This is my master, so her last name is now Smith. And if I go back over to my other server, and I do a select statement here, her last name is now Smith. So whatever changes I make on the master will automatically get replicated to any of the slave computers. Be aware, I cannot do updates on the slave. I can only do updates and inserts on the master. I do all my select statements on the actual slave computers. In this lesson, you learned what replication is and how it works, different ways that replication can occur, how MySQL handles replication, the difference between the slaves and the master, the importance of the binary log. Remember, the binary log is what is actually being used to replicate all the data, how to configure MySQL to enable replication, and how to troubleshoot replication.